In this video, we will solve a question involving an infinite geometric sequence with natural logarithms. Here is the question. The first three terms of an infinite geometric sequence are given. In question A, we need to find the common ratio. And question B says, the sum of the series is 256. Find x. Let's start with question A. To find the common ratio of a geometric sequence, we divide any term by its preceding term. Here, we can divide the second term by the first term. So the common ratio r is equal to ln x power of 16 divided by ln x power of 32. As we know from this property of logarithms, we can put the power of m down and multiply it by ln x. Therefore, r can be written as 16 times ln x divided by 32 times ln x. By cancelling logarithms, we would have 16 divided by 32, which is half. So the common ratio is half. Now, let's move on to question B. We're given that the sum of the infinite geometric sequence 256. Here is the formula for the sum of an infinite geometric series, where u1 is the first term and r is the common ratio. In our question, the first term is ln x power of 32 and r is half. We substitute in the formula. We can write 32 times ln x divided by 1 minus half equals 256. By simplifying the fraction, it becomes 32 times ln x divided by half equals 256. By cross-multiplying, 32 ln x equals half multiplied by 256, which is 128. Now, dividing both sides by 32, ln x is equal to 4. Therefore, if we need to get x, it would be equal to e to the fourth power. Let's clarify the last equation in a different way. We will raise both sides of the equation to the base e. Now, as we know from this property of logarithms, ln and e cancel each other, since the natural log has base e. Therefore, we have x equals e to the power of 4.